So we take a look at the first example. Find the point or points where the normal line is vertical for the function f of x equals 8 over x squared plus 2. Alright, what is it asking? It's saying find the point or points. So we need, our answer is going to be an ordered pair where the normal line is vertical. That's weird. Vertical lines have a slope that's undefined. How do we say that the derivative of this, how do we say that the derivative is undefined? That's weird, right? We don't have to say that. We don't have to think about that. Since the normal line is perpendicular to the tangent line, well, if the normal line is vertical, if that's the normal line, then the tangent line has to be 90 degrees. That means the tangent line is horizontal. It's horizontal. So that's cool. Since the tangent line is horizontal, we know that would be a slope of 0. So it's asking, find the points where the normal line is vertical. That's the same thing as asking, find the points where the tangent line is horizontal. So that means the same as finding where the tangent line is horizontal. So that's what we're going to do. For what x values is the tangent line horizontal? Well, horizontal means it has a slope of 0. Okay then. I will take the derivative. Maybe I use the quotient rule, you know? I use the quotient, you know? Hello? Hi. Alright, so f prime of x, that would be low d high, x squared plus 2 times the derivative of the top, that's 0. Oh, it just goes away. Low d high minus high d low, that would be 2x plus nothing, yeah, derivative of the bottom. Low d high minus high d low, all over low squared. That would be x squared plus 2 quantity squared. Alright, so that's, I'll clean it up a little bit. So now we have this, and we're asking when is the tangent horizontal, or when is the normal vertical. Yeah, it's the same thing. So that means I will make this a 0. I will make this a 0 right there, like that. And so I have this like that, over this right here like that. And I take this, I multiply both sides by the x squared plus the 2 squared. I do the 2 both sides. Pretty much goes away. Huh? Does not matter. 0 times that is still 0. Doesn't care. So we have this. Oh, look at x equals 0. Okay. But he said find the point. Okay, so I know that when x is 0, I have a tangent that's horizontal. And that implies that the normal line is vertical. So that's good. But it says the point, so I need a y value. I have an x value. How I get a y value? Well, I plug it in. So that's what I'll do. F of 0, that's equal to 8 over 0 squared. Is it plus 2? I think it is. Right? Yes. Okay, 0 squared, that's just 0. So this is 8 over 2, which is 4. So my y value is 4, because that's going to be my y value. And then here's my answer. Here it is. Right? What was it? 0, 4. That's when the normal line is vertical. Sweet! We're done with that problem. We're gonna try another. Alright, this one looks like a nasty one, but it's gonna be okay. It's gonna be okay because we're like pros in math. We get paid for we're good at math. So find an equation for the normal line to the function when so find an equation for the normal line. Well, first of all, I know I need to use the point slope form. So there we have that, and I already have x1. This is my x1. That's my x1. How do I find a y1? Let's find that right off the bat. That's just plugging in. Maybe I'll do it in a different color. y1, you get it by plugging in your x value to your original function. I know I need one, so I might as well get it. So y1 will equal 2 times Cotangent, what is cotangent? Cotangent is, well, if tangent is sine over cosine, then cotangent is cosine x over, whoops, 2x, right? It's 2x. 2x over sine of 2x. Why'd I put the 2x in there? Because it's right there. Okay. So that's the same thing. And the only reason I did that is so when I plug this in, I know what's going on. So I have y1 will equal 2. I shouldn't have put the y1 there. That should just be y. I'm going to erase this. There. So y1 is actually 2 times cosine, this is eraser, 2 to cosine of the 2 times the negative 2, that's negative 4 pi over 3, divided by sine of negative 4 pi over 3. Okay, well, I have to figure out what cosine of 4 pi over 3 is, and sine of 4 pi over 3 is actually negative, so let's see. The way I do it is by drawing a unit circle real quick. And I know that this is 1 pi over 3, this is pi over 4, this is, sorry, I messed that up. Pi over 6, pi over 4, pi over 3, pi over 2. But we're going backwards, huh? I'm just going to draw each of these tick marks. So there we go. I know that the positive direction is going that way. And the negative direction is going this way. Ooh, that's interesting. And I have negative angles here. Oh, negative 4 pi over 3. Okay, so this is how I do it. This is just trig review. Pi over 3, that's this size of a slice. Is it not? So that's 1 pi over 3. This is actually supposed to be the same size. That's 2 pi over 3. And then this is also the same size, 3 pi over 3, and then this would be 4 pi over 3, because there's 1, 2, 3, 4. That's beautiful. But that's in the positive radian direction. So I'm just going to do the same exact thing, except for go in the negative radian direction. So I know that this size slice is 1 pi over 3. And it's the same as that slice, so that's 2 pi over 3. And then 3 pi over 3, this is all negative. That's good because here's pi. 3 pi over 3 is just pi. And then 4 pi over 3. So I end up at that point. That's how I figure it out. If you figure it out in different ways, that's fine. Just whatever you're comfortable with as long as you can do it. So really I'm looking for cosine of this like what's the cosine at this spot, and I know already just because I know the unit circle. Well, I think I know. The cosine would definitely be negative 1/2, and the cosine is the x coordinate, sine is the y coordinate. Sine, that would be positive, I think, is root 3 over 2. That's just because I know the unit circle. Here, this distance, that's the y value. That's definitely root 3 over 2. I can see it with my, I can't see it's eyeballing it. That's supposed to be 1/2 if I drew it perfectly. But I'm comfortable with the unit circle. So there we go. So now I know what y1 is. y1, or I can figure it out. y1 is equal to 2 times cosine of that. Well, that's negative 1/2. And divided by sine of that, well, that would be root 3 over 2. And I'm going to flip and multiply because I got a fraction on the bottom. So y1 is equal to, well, that cancels. So I get negative 1 in the top and 2 over root 3 in the bottom. So what is that? y1 is negative 2 over root 3. If I rationalize, this is a lot. I'm showing you too much. Hopefully this is a review and you don't really need this, but if you do, there it is. y1 equals negative 2 root 3 over just regular 3, because when I multiply that, the radical goes away. Alright, so now I have my y1 and I have my x1 already. It's up to me to find the slope. Oh, maybe I should do that in the next part. I think I will. Sorry.